All right, guys. So I do know that a good number of y'all were gone yesterday for the interviews. And again, we're just going to go on and go back over Chapter 7. This isn't the first year that I've had to go back over Chapter 7. I've had to do this before. And it's not that all of y'all were doing terrible on the test. It's more that looking back through the tests that y'all took and what y'all were doing and how y'all were scoring, y'all could do so much better. It's a lot of it is very little things. You're missing one key step, one key thing to it that's keeping y'all from being able to do it.
Are we going to go over the x parentheses x minus 1?
So we're going to go back over addition, subtraction, multiplication, division, and solving. Those are the main three we're going to go over. And you're going to retake the test. The test is going to be different. I'm going to make up a new test for y'all to do. Yes. Least common multiple, I'm throwing out. Yes.
So are you grading this test?
No. I'm not going to grade it at all.
Okay.
Now, you can still turn the homework in. If you haven't got it done, you can turn that in. Huh? Now, there are going to be 3 more assignments, because again, we're going back over it. There are going to be 3 more assignments with this here. So there's going to be a worksheet over addition, subtraction, worksheet over multiplication, division, and worksheet over solving. We're going to do those. Also, next Monday, y'all aren't here. There is no school Monday, parent-teacher conferences. Tuesday. Tuesday, me and Miss Kendall will not be here. The new mathematics standards for Oklahoma are being released. They redo this math standards every 4 years. They're holding a professional development on Tuesday to kind of go over the new standards. It's nothing really new. It's just telling us what new things they've added or ways they've rephrased the standards of what we have to cover. So they're holding a professional development we're going to go to and kind of get more of a rundown on what the new standards are. Not really. We find it interesting, so there's that. Now on Tuesday, there's 1 of 2 places. I don't know where y'all are going to be yet. Because if there's a sub, you're going to be in here. If not, you're going to be in the library. It's going to be one of the 2. Now, in either case, if you're in the library, I'm going to give the test for those of you who took it and those of you who haven't, because those of you who haven't, I already have a test with your name on it, just the way that I do those up so that you have it. For those of you who know, if you missed a test, when I hand it back, it's already got your name at the top. So on. You're going to get those back, and I have a video already done going through the entire test. And so on Tuesday, what I want you to do is go through the test and see how they're worked and what it is. And I hope that it'll help you see what it is that you were either A, overthinking, or B, kind of misunderstanding on those. All right, so you'll get them back and go through them and fill those out. I will make that a grade so that y'all get points, so you'll turn them back in. If it's in the library and you don't feel comfortable giving it to them, that you might think one of them, not going to say who, might lose it between there and here. Again, not saying any names. Hang on to it and just turn it in Wednesday. I'll take them there, okay? That way you've seen it. You do get points for going through it and doing it, but it'll help kind of see, okay, what was I overthinking? What was I missing on those steps? Now, one of the positive things, inverse, direct inverse variation or neither. Every single one I looked at, y'all got all 6. Y'all did great there. So we're mainly looking back at addition, subtraction, multiplication, division, and solving. Seeing this again. Yes? You'll need to fill out, follow along with it.
Do we have to do all of them?
I would want you to. Because again, it will help to see them. Now, looking at this here with addition, subtraction, the main thing for us to be able to add or subtract 2 fractions is the denominators have to be the same. And whenever we start addition, subtraction, the first things we're doing, we're just trying to get the denominators to be the same if they weren't already to begin with. We're not really messing with the numerators. We're not trying to factor the numerators at this point. Whatever the numerators are, we'll leave them alone. If we have to multiply, we'll multiply, but we're not factoring at this point. If we're factoring anything, it's the bottoms of the fractions, the denominators. Now, looking at this here, both of the denominators are x minus 5. They're already the same. And since they're the same, we can add the numerators. I didn't do this a lot during the lessons, but we can really think of them with parentheses around them. We don't need it for addition because the plus in front of the x plus 2 is not changing. It's still going to be x plus 2. The real reason to do this is if this was subtraction, because that subtraction side is applied to not only the x, but the 3, because we're subtracting it from it. So we could have left this as just 6 plus x plus 2. Now that we have it all in the same fraction, we combine like terms. Our only two like terms are 8 plus x, or x plus 8 over x minus 5. Because once we finish combining like terms, we have it as one fraction. Now we would factor. We wait to factor to this point here. Because as I was walking around between all three Algebra 2 classes, there were some, when we did addition subtraction, when y'all were working on it, you were factoring at the beginning, at the bottom and the top, which is going to make it hard to work with because we can't add it if we have them factored. Now this here is it. Most of the ones we'll cover today, because we'll cover this today and tomorrow, aren't going to have a whole lot of factors simplifying out. This one doesn't, the next one will, but that there is the final answer. Questions on this here? Because we normally do pretty well, especially if the denominators are already the same. If they're already the same, we can just add and subtract the numerators. Now looking at this one here, the denominators are already factored. X plus 5 times x minus 2. That's already factored. That's already in factored form. We're good there. All right. Yep. No. So, looking at this here, now the numerators, the x squared plus 3x minus 2 doesn't factor to begin with. There's no way to factor x squared plus 3x minus 2. It just doesn't factor. Now the 4x plus 12 does have a greatest common factor, but we're not going to factor it. Because for us to add or subtract, we need to be able to combine like terms. If we factored 4 out, we would have 4 times x plus 3. But we can't add anything to it because we would have to distribute the 4 back through. Whenever we have parentheses, we have to distribute it through and then be able to add or subtract. So whenever we're looking at addition, subtraction, we don't factor the numerators because there's no way to combine like terms. Because whenever we do these here, we factor the denominators so that we can get them to be the same. Because once they're the same, then we can add or subtract the numerators respectively. And also, whenever we add or subtract, once the denominators are the same and we combine them, it just becomes 1. We don't have to do anything to it. And since the denominators are the same, we can add the numerators. Now, we don't necessarily need the parentheses because we are adding. The 4x and 12, their signs will stay the same. The 4x was positive, it's still going to be positive. The 12 was positive, it stays positive. But now we can combine like terms. If it will. So the x plus 5, x minus 2 will stay the same. X squared is our variable with the biggest exponent. Does it have any like terms with it? Any other term in the numerator with x squared? No. Now the first set of like terms are 3x and 4x. 3x plus 4x is 7x. And negative 2 plus 12 is plus 10. Any questions on any of this here so far? This is where we would factor the numerator. Once we finish combining like terms, we have it simplified down as far as we can go. Now we will want to factor the numerator just in case there is something in common on top and bottom, where we get a set of factors or a set of parentheses that has x plus 5 or x minus 2. Now 7 or x squared plus 7x plus 10. Is there a number or variable that will go into all three? No. X squared is by itself, so most likely there's not a greatest common factor, but that's a good place to start when factoring. Two sets of parentheses. What would our signs be? Positive and positive. Yes. The third sign, the term 10 is positive, so the signs are the same and match the sign of the middle term. Plus and plus. Now we look at the factors of the first and third term. Yes, factors of x squared are x and x. Now factors of 10 are 5 and 2, and the other is 1 and 10, but we want 5 and 2. The factors for the other, yes. Because when we distribute back out, if we multiply this back out, x times x is x squared. X times 2 is plus 2x. 5 times x is plus 5x, and 5 times 2 is plus 10. So multiplying these two give us our 10, which is our third term. The x times x is x squared, gives us our first term, and the cross of those two gives us the middle term. So that's what we're looking at when we're looking for x and x, 5 and 2, first and third terms. Now it works out that we do have an x plus 5 in common on top and bottom. And any time we divide something by itself, anything divided by itself is 1. Because 7 divided by 7 is 1. Anything divided by itself is 1. So these simplify out, become 1, leaving us with x plus 2 over x minus 2. Any questions on this one here? Yes.
So, it's x and then times x and then x times 2.
Yes. When we distribute back out. Because we can do that to check to make sure we did factor it correctly. And the main one to check is the x times 2 and 5 times x. Because x times x is x squared. But where did we get x and x from? The factors of? So we should expect it to factor or multiply back together to give us x squared. Where did we get the 2 and 5 from? Factors of 10. So those should multiply together to give us 10. The only one that will really change in most cases are the middle two. So those are the ones we check. X times 5, 2 times x. Any other questions on this one here? So those of you who were here yesterday, hopefully this problem looks familiar. This one is straight from the test. Yeah. Yeah. But any questions on this here? They're pretty good. Let's look at this one here. The denominators, are they the same already? We will need to factor them eventually if there is something in common on top and bottom. But if they're already the same, we can subtract the numerators from each other. And again, at this point, it doesn't matter if the numerators, the tops of these fractions will factor. We need to add or subtract them first. We need to do the addition or subtraction first. Now, up to this point, we've only done addition problems, so having the parentheses really didn't matter. But for the subtraction one here, we're subtracting everything in the top of the second fraction by everything in the first one. So we're saying that we have x squared minus x squared. We have negative 2x minus negative 4x. And 3 minus negative 5. We have to apply or distribute this negative through everything here, not just to the x squared. So what we're going to do here first is apply this negative to everything in the second set of parentheses. So we apply the negative to x, which gives us negative x squared. We apply the negative to negative 4x, and a negative makes a positive. And a negative 5 is plus 5. Now the numerator, we need to combine like terms. Well, our first set of terms that we can combine are x squared and negative x squared. X squared minus x squared is 0. Anything, if we subtract it from itself, we have 1x squared minus 1x squared. 1 minus 1 is 0. These will simplify out. Next one we have is negative 2x plus 4x, or 4x minus 2x is 2x. And lastly, we have 3 plus 5 is plus 8. Over x squared plus 7x plus 12. Now that we have everything simplified as far as we can, now we factor. Because with addition and subtraction, we don't factor the numerator till the very end, once we finish adding and subtracting everything together. And if we look at 2x plus 8, is there a greatest common factor between those two terms? Yeah. 2. 2 will go into both. So we take 2 out. We factor 2 out. We're essentially dividing both of those terms by 2. 2x divided by 2 is x. And 8 divided by 2 is 4. When we factor something out, factor greatest common factor out, we're essentially dividing each term by that. We place what we divide everything by out front, and then simplify everything inside the parentheses. Yes?
Why did we divide 2 out?
Because what we want to see is if we're able to factor the denominator, and we have a set of parentheses that matches x plus 4, then they will simplify out. And that's what we need to see. Now, 2x plus 8 most likely is not going to match up. But since there's a common factor of 2, we pull it out to see, will it match up to something in the bottom of the fraction? Now, a way that we can see this is in each of the parentheses, the two terms that we have. The x, or the term that comes first, yes, sir? Yes. Now, one way we can kind of see that is the x and x come from x squared, yes? The two numbers that go in there, the second terms for each set of parentheses come from the third term, yes? And if we look at this here, so x squared would give us an x term in both of the bottom fractions, yes? Now, is 4 a factor of 12? 3 and 4. It is a factor of 12. But if it had been, say, 15, 4 is not a factor of 15, so there's no way that it could. Now, this is not a guarantee that we'll get x plus 4. But hey, 4 is a factor of 12. X is a factor of x squared. So there's a chance that x plus 4 could be in the bottom of the fraction. It's kind of a way to look at it. Now we factored it. Yes, because the 12 is positive, plus and plus. That's that middle term. Factors of x squared are x and x. 3 and 4.
So what if it's plus and then minus up there?
If this had been x minus 4 and x plus 4,
Okay, on the x squared plus 7 plus 12 was minus. How would you know what to put on the factor?
so if the third term, it's all based off the third term. If the third term is positive, the signs are the same and match the sign of the middle term. And the reason for that is when we multiply to get 12, we're multiplying 3 and 4 together. If they're both positive, a positive times a positive is a positive. Two positives multiplied together gives us a positive. If 3 and 4 were both negative, a negative times a negative is a positive. So this here, if they were both negative, it would be positive. If they're both positive, it's going to be positive. Now, the middle term, we do this here. X times 4 and 3 times x. X in both cases is positive. That's also why we factor out the negative if x squared is negative. So this here, x times 4 is 3 times x is plus 3x, which, yes, does give us 7x, yes? If both of these had been negative, if the 4 was negative and 3 is negative, negative 4 times negative 3 is still positive 12, yes? But x times negative 4 is negative 4x. X times negative 3 would be negative, because if this was, both of these were negative, would give us a negative 7x, which means the middle term is now, since the third term was positive and the middle term is negative, they're both negative. Does that make sense? Yeah, that's why this works with match the signs of the middle term. Now, if the third term is negative, what's the only way we can multiply two numbers together and get a negative? If one of them's positive and one is. So if the third term is negative, the signs are opposite. One is positive, one's negative. It doesn't matter, because if the third term is negative, one's positive, one's negative. It doesn't matter about the middle term. The middle term only matters if this third term is positive. If the third term is positive, then those signs are going to match with whatever the middle term is. If the third term is negative,
Then it'll just be whatever.
one's positive, one's negative.
Okay. And if it's positive, the middle term is negative, then they'll both be negative.
Yep, because if this term is negative, the third term is negative, it's not really mattering what the sign of the middle term is. One's positive, one's negative. Any other questions on this here? Now, addition and subtraction, especially when the denominators are already the same, is not that bad because they're already the same. We don't have to do anything to them. Now here, this is the first one where the denominators are not the same. We need to get them to be the same. We need them to be the same so we can add or subtract the numerators. And if we look at both of them, we need to get x squared and 7x to be the same. We're looking for the first expression that will make them be the same. Well, the one on the left, we have x squared. How many x's do we have? 2. The one on the right has how many x's? So if we're going to get them to be the same, how many do they need? 2. Because when we do this, we're going up. We're not going to try to go down. So if one of them has 2, one of them has 1, we need them to both have 2. And to do that, we're going to multiply the fraction that only has one x by an x over x. Yes? Out of the x squared, it would be possible, but it's going to make it harder to work with because we would have to divide the x out of x squared. And what that would look like is multiplying top and bottom by 1 over x, which does work because it will make x squared into x. Now the numerator is 2 over x. Now we have a fraction in a fraction. So we try to avoid going down, decreasing any of the values. We want to go up. Since one of them has 2 x's, we want the other one to have 2. Exactly. This one has a 7 multiplied by it, so the other one needs a 7. So we're going to multiply top and bottom by 7. Now this seems very weird doing this here, but what is 7 divided by 7? 1. So we're just multiplying it by a fancy version of 1. And even when we multiply this, 7 times 2 is 7 times x squared is 7x squared. But 14 over 7 is the same as what? 2 over, did we change its value? No, we haven't changed its value, but for us to be able to combine these, we need the denominators to be the same. That's what we're doing. We're trying to get the denominators the same so we can actually subtract these. Because on the other side, x divided by x is just 1. And even when we multiply it, 3 times x is 3x. Because that's still the same, 3x over 7x squared is still the same as 3 over 7x. They're still the same. And it is very tempting to cancel those out or simplify them down. But if we do that, we can't actually subtract. Because 14 over 7 would reduce to 2 over 1, but we'll leave it. Because for us to be able to subtract these, we need these denominators to be the same. And when we subtract, the denominator will be 7x squared. Now, it's kind of nice for us here, since there's individual terms, we're doing what? We're subtracting 3x from 14, which would be 14 minus that's it. 14 and 3x do not have any like terms, so we can't subtract them. There is no greatest common factor. There's not a number that will go into 14 and 3. That's it. This is as far as we can take it. Questions on this here? So this is just subtracting still. Just the denominator is not the same, so we had to get it to be the same. We're just seeing what do we need to multiply both of them by to get them to be the same. And we talked about least common multiple or least common denominator. All this is what do we need to get those two to be so that they are the same? And the least common denominator, least common multiple for this here is 7x squared. That's what it is. That's what we need the denominators to be for us to be able to add or subtract. So when we went over least common multiple, least common denominator, all it was getting at is what do we need to do to make these to be the same so that we could add them or subtract them. That's really all it was. Now we had to multiply one of them by x over x and one of them by 7 over 7 so that both of them were 7x squared. Questions on this here? I think for the most part dealing with these monomial terms, 18x cubed y and 27x squared y, I think these are a little bit harder to see what the least common multiple is than it is for just sets of parentheses. Because with sets of parentheses, we can look at them and see, okay, what does one have and one doesn't? We can visually see it. It's a lot easier to see than it is to see what is the first number that 18 and 27 was the first number we can make both of these be. Because 9 is the greatest common factor. 9 is the smallest number that will go into both. The biggest of the numbers that we can divide everything out of. Least common multiple, we're trying to get them to be the same, we're going up. There's two ways to do it. One, the graphing calculator, we've seen that. I showed you guys that once. If we hit math, button go over, down at the bottom, LCM, LCD, we'll do that. And you can put two numbers in and it'll do it for us. The other method is finding all the factor or kind of multiples of 18. So we can do 18. Add 18 to it and get 36. If we add 18 again, we get 54. We add it again, we get 72, 90. And I can sit there and just list out every multiple of 18, just going on. We can do the same thing with 27. Next one I get is 54. Well, first number both of them become is 54. So the first number, the least common multiple between 18 and 27 is 54. So for us to be able to add or subtract them, the 18 and 27 both need to be turned into 54. Because when we add them, each one of these denominators is going to need 54. Yes, but we need to figure out what we need to multiply it by. Because 18 was 1, 2. The third one, 3 times 18 is 54. So we need to multiply the 18 on top and bottom by 3, because 3 times 18 is 54. Now we do the same thing with 27. Well, 1, 2 over 2, because 27 times 1 is 27. So 2. In doing that, the denominators both now have 54, yes? Now we can look at the x's. One of them has 3 and the other has 2. So if we want to be the same, they both need to have 3, yes? The one on the left already has 3. Do we need to do anything with that? The one on the right has 2. So to get to have 3, we would multiply it by x over x, which would give us x to the third on both. Now y, yes. Because one of them has 1, the other has 3, so both of them need to have 3. So the first one we need y squared over y squared. It already has 1, it needs 2 more. Now anything we add over this, we'll end up having to pull out later. We have to factor it out later. Now we just need to multiply the numerators. On the left, 3y squared times 1 is 3y squared. Multiplying by 1 is nice. There's only one number that's nicer to multiply by, and that is 0. On the other side, we have 5 times 2x is 10x. Now lastly, what do we need to do? We need to add the numerators together. Three y squared plus 10x. So are they like terms? No. So we can't combine them. Because they both either need y squared or they would both need x for us to be able to combine them. So that is, we can't actually add the two together. Now, is there a number that will go into both 3 and 10 evenly? No. So we can't factor that out. X and y, they don't have any like variables to factor out. That's the lowest it'll go. And again, whenever we add or subtract, we wait to the very end to factor the numerator to try to see if there's like terms to simplify out. Because if it was minus, we would be looking at difference of perfect squares. But this here is as simplified as it gets. Because on the test, the only ones we would look at it possibly factoring if one of them squared is difference of perfect squares. The first term, the one with y squared, 3 and y squared would need to be perfect squares. So we're looking at 4, 9, 16, 25, 36. And the same would be true for the other term. And again, whenever we factor any of these here, the first thing I would look for is greatest common factor. Something that divides into every term. That's where I would start. Because sometimes that'll make it easier to work with. Now this one here is going to be the last one we look at today. We'll finish this up tomorrow. These here, I find these easier to work with. Because one of our denominators is x plus 3, the other is x. And we can easily look at this. Well, one of them has x. Does the other one have an x? Well, it has the x plus 3, which is a term. Wherever we have addition or subtraction, think of them as a single term. So the x plus 3 stacked together, it is one object. Does this first fraction have an x plus 3? No, so for us to be able to add or subtract, it needs an x plus 3. So we can times the top and bottom by x plus 3. Because as we said already, 7 divided by 7 is 1, yes? X plus 3 divided by x plus 3 is 1. Anything divided by itself is.
So on the other side, we won't have to do it.
So it's just x. Do we have an x? Yes. Because x, yeah, x and x plus 3 are two separate terms. They're two different things. The x plus 3 is together, the x is by itself. Now the denominators, we don't have to distribute this through. We're not going to multiply it through. Because as we've seen so far, when we subtract these, we subtract the numerators, we just rewrite it as a single denominator. We don't have to combine terms on the denominator, do we? It just becomes that 1x times x plus 3. So there is really no reason to multiply it out. Because we can, but at the end when we check to see is there something in common on top and bottom, if we multiplied the x and x plus 3 together, we would have to factor the x right back out. There's no combining in the denominator, it's just that one term, so we leave it alone. We leave it as x times x plus 3. We don't do anything to it. But as we've seen so far with the numerators, I'm going to have to combine like terms. I have to see what the like terms are. So at this step, we have to multiply the 5 with the x and 5 with the 3. Because 5 times x is 5x plus 15. X times 7y is 7xy. Because any terms that are in common on top and bottom, or not on top and bottom, just on the tops of these two fractions, we'll have to subtract them. And the only way we can subtract them is if we have those multiplied together, we have those simplified. Well, it'd be helpful if I actually had it written right. Now that negative is only applied to the 7xy. Now 5x and 7xy are not like terms because the 7 has xy, the 5 only has x. There are no like terms to combine there. Now 5 and 15 do have a greatest common factor of 5, yes? But do all three? No. So we can't factor the 5 out, it won't be helpful there. That there is as simplified as it gets. And again, most of these that we've done except for those two don't have anything to simplify. Because again, I'm wanting to focus more on what we're doing with the addition and subtraction.